put that graph. It's right here. Okay, so there's a graph of some polynomial function, which is actually written down here, but it's a tiny little thing, but that's okay. If I want to think about what happens with these values here, a point that's up here, say that point right there, if I do the absolute value of this now, if I do absolute value of that polynomial function, is that point going to change? No, that point's going to stay the same, right? It's already got a positive y value. Is this point going to change? Is that point going to change? 0? This one? That one is going to change, right? When you do the absolute value, that piece there is going to be up on top. And this piece over here, this chunk's going to be up on top. Okay? It's reflected like that. The parts that are positive stay positive. And the parts that have negative y values get reflected, right? So just this part and just that part reflect. And go back to this page and think about why, right? Which points changed here? Which were the ones that changed? Let me erase these and highlight them again. Sorry, what were we going to say? Which ones changed? Well, which points out of the list changed? The ones with what? Yeah, the ones with negative y values, right? The y values change. The only ones that change are the ones with negative y values. If it has a negative y value, the y value becomes positive. Otherwise, the point stays the same because it's already a positive number. You're performing a function, and then you're doing the absolute value of that function, of the result, right? Of the resulting number. It's not much harder than that, I don't think. Okay? The point that whatever function you put in here, it's gonna get reflected up on top. Now, the other things that are in here, this is, you could look at this as the absolute value of something that you know how to graph. Without the absolute value in here, what is that going to look like? It's just a line, right? So it's some kind of line through down here. I'm not going to draw it very well, but like that. Something or other like that, right? What is it going to look like when we do the absolute value of that? I will maybe leave it up to you, but think about exactly what we just said. The y value, the points that have negative y values are the ones that change. I am not going to do that one for you now, but you can think about it. That you're going to be able to do. And then eventually we're starting to think about if you incorporate other transformations. This has a few transformations involved, and I would like you to think through how you get, this is my hint to you for this. Right now this is kind of H-level question. How you get y equals f of x to look like this. One of the keys to doing this unit is to not just think of it like this. I know some of you would like to say, well, when there's a 2 on the end, that does this, and when there's a 3 there, it does this, and when there's a this thing, it does that. Just, you don't have to memorize stuff if you just think, how can I start with this and end up with that? There's 3 things involved here. There's a vertical expansion of 3, right? There's, what does this 2 outside here do? If it's outside of all this other stuff, if it's outside of the function, it's going to be which direction? Yeah, it's going to be down, right? Vertical translation down 2. And there's also the absolute value. To get the function to look like this, think about what order you have to do those things. Try one to go first. How about try we go down here first? If I go down first by 2, what does this function turn into? It goes from y equals f of x to y equals f of x minus 2. So I did this one now. Then if I did the absolute value, I'm doing the absolute value of this whole function. If I'm doing the transformations in this order, if I first go down to, and then I do the absolute value, I'm doing the absolute value of the entire function. That as well, right? That whole thing. It's already looking wrong, right? That's not what we do. To get this is something different. And then if I did the expansion, it would be replacing y with a third y or a 3 right there. This would represent if you went, what did we do first? We went down 2. Then we did the absolute value, down 2, absolute value of the function. And then we did vertical expansion times 3. We don't want that. We want it to end up like this. So you have to think through what order is required to get f of x to look like that. That's why some of those questions before were step by step. How do you change this function to that if you do it in this order? Make the changes one at a time. Whatever craziness your function looks like, if you replace it, if you replace all the x's with something, it'll make a change horizontally. If you replace the y with something, it'll make a change vertically. Okay? Are we sort of okay with this? You can experiment with it on your calculator. Put some, just whatever random polynomial function in there, and then put in absolute value of that thing. Let's make up some kind of crazy wacko function here. Tell me a button that I could push on here to do. Why don't we go log of x minus sine. You haven't graphed trig functions yet, have you? That doesn't matter. It's a calculator. You don't need to know what they look like. Plus 3. I don't know what. I mean, that's probably, I have no idea what this is going to look like, by the way, but let's go this. This could actually be good, or it could be a miserable failure. Is there any kind of graph anywhere on there? There's something. Oh, I'm probably in the wrong mode. Later, oh no, I'm in the right mode. Anyways, whatever it is, who knows? That's a really bad example. How about this one? We're going to start doing trig functions. Let's just do sine of x. At some point pretty soon we're going to do trig functions, graphing them. That function actually looks like this. I'm going to actually do a different zoom so you can see it a little more close up. I'm going to do zoom trig. You have no idea what that function is, maybe. But you do know that having seen it, there's what it looks like. If I was to now graph absolute value, which is right here, under numbers, absolute value of sine of x, that crazy function you haven't seen before, it's absolute value of that function. So given what the original graph looks like, what's this going to look like now? It's going to look like, it's not going to go below, right? So it's going to graph that one again, and now this, I was going to do it while it's covering it up. I should have done this. What I should have done is change this. Oops, no, that's not what I want. Turning into a miserable failure already. We're going to get this back. X, close that. I should have done this. This is just so sophisticated. 2009 technology, you can draw a thick line. It's amazing. So there's the original function. That was sarcasm, by the way. There's the new function. It's a 20-year-old calculator in a nice new shiny box in some cases, a TI-84. That's the absolute value. Whatever the function looks like, all the y values become negative. If I was to now do this, okay, so let's say while we're on this subject of these weird functions, if I was to do now, if I was to do absolute value of sine of x, but then go down 3, I would do that, right? What order are those transformations going to be applied? Absolute value of sine of x, and then the minus 3 is outside of the absolute value. What happens first? What happens second? Absolute value happens, then I go down 3, right? So it's going to be down here, right? It's okay for it to be negative. It's lower. I think this is the reason I'm showing you this is because I think grade 12 students have a tendency when they first learn absolute value, as soon as they see these two lines in it, and then they draw a graph and they say, wait a sec, my graph ended up here. I'm not allowed to have this, so I better say it's wrong and fix it, right? If there's an absolute value but then some other transformations, it can be negative. If the last thing is absolute value, then there can't be any negatives. If I was to do a function where it's all negative, then, if absolute value is outside of it, then it'll all end up positive. I've probably done more than, you can still think about this. There's lots to think about there, which I would like you to do right now. It's going to take you maybe